Alright guys, so now that we've got their basic background here with the gray and the system config button, the next thing we're going to do is we're going to put in a digital display to show the value, and we're going to show a graphical display on this tank here based on our 4 to 20 milliamp signal coming in. So I've got an inductive sensor here that is providing me with a 4 to 20 milliamp signal going into my HMI, and if we take a look here and I change the signal here, then the value should start to go down. There we go. All the way down to 4 milliamps. Now I'm using an inductive sensor, and the piece of metal that I can press up against the sensor gives me the smallest value of 4.5 milliamps. But you can see here that the value is identical between this guy right here and the value that we're seeing on the meter right here. And as I move that piece of metal away from my inductive sensor, then I'm simulating that the tank is starting to fill. And as that signal comes in, there's my 50% at 12 milliamps. And then there's 16. And finally, the full 20 milliamps to show a full tank. You'll notice that once it goes above 20 milliamps, then this value here is 22, but the HMI is still reading the maximum value, right? Because that's the max value that's coming out of my PLC. Okay, so we need a way to be able to drop in this tank, and then we need to connect that guy into our PLC variables so that we can have this graphical output of our 4 to 20 milliamp signal coming in. All right, guys, let's go through it step by step. Okay, so first thing to look at is my PLC program. So I've got a compare statement here, and I'm looking at my word input here on my PLC. And the first rung here is saying that if the milliamp current is between 4 milliamps and 8 milliamps, then turn on the first light. You can see here that the value is 4.37 or 4.38. And as I move this guy away from my inductive sensor, then the input is increasing, and once it gets above 8 milliamps, then the second light should turn on. There we go. Okay, so there's my, if I can just hold my hand still, there's my second light on. The second rung here is saying that if it's greater than or equal to 8 milliamps or less than 12, then keep the second light on. The third rung right here is looking at a value greater than or equal to 12 milliamps, but less than 16. So if I move it away just a touch more, there I am at 14 milliamps. So this value right here is changing based on the distance away from the inductive sensor. And then finally, the last range is between 16 and 20 milliamps. So as this value goes above 16, then my final light turns on, and I can keep increasing up to the 20 milliamps there. Beautiful. Okay, so that's my PLC program. You need to have some sort of PLC program set up in order to develop an input, and in this case I'm using a word here, IW1.0, and I'm going to look at this on my HMI. So we've got to set up the HMI to look at our PLC program, specifically looking at this word input that's coming in from my analog input card. Now, in order for the PLC and the HMI to work together, we need to go to, just let me disconnect here, and then we can go to describe. Okay, so I'm coming over here from the program that I was on before over to describe. And I've dropped in this slave right here. The HMI is going to be talking to the PLC, but I need to put this into my describe window here. So the place where I found this is over here. It's a network element. So we're coming over here to the right-hand side. We're going to network elements. We're going to open up this window. This is using Modbus communications. So we're going to open up the Modbus. And this HMI that I'm using is a Magelis HMI. So I'm going to grab this Magelis and drag it over onto the page. And there you can see an identical Magelis right there. Okay, this one, when we open it up, has, let's see, the defaults are slave 1, Modbus, and master. This one right here is, again, slave 1, Modbus, and address number 1. So let's see. We've got slave 1, Modbus 1, and what did this one say? This is slave 1, Modbus, and master. So we're going to change this master here to 1, and then hit OK. I'm not going to do that because I already have it set up over here. So we're going to change this from the master to the slave 1. Okay, so double clicking on here, keep it as slave 1, keep it as the Modbus configuration, but change this from master to address number 1, and then hit OK. Okay, once you've got that set up, then you can double click on the Ethernet portion of your PLC now. So we're going to double click on here. And the IP address that's set up for that first slave is right here. So you can see that my PLC has an IP of 192.168.2.11. So I've just sequentially gone down, and my first slave, which is the HMI right here, and we just set that as the first slave. We now need to set the IP. So I've set this as 192.168.2.12. And you can just double click on here, you can change that value. Once everything's set up, then you can hit OK. Okay, so just to go over that one more time, we came over here to network elements. We opened up the Modbus elements. Then we came over here to the Magelis, and we grabbed the Magelis and dragged it over. And then we double clicked and we put slave 1, Modbus, and 1. And then we hit OK. That set up the first address as our HMI. Then we came over here, we needed to give that HMI a IP address. So looking at our PLC, or the LAM, if you're doing this in the lab, the Lamacoid that provides you with the IP for the PLC, and it also provides with the IP for the HMI. Double click here, provide it with the appropriate IP for your HMI, and then hit OK. Okay, the next thing we're going to do is we're going to come over here to Program. And then we're going to go to Program again, because right now we're in Debug. So we're going to go to Program. Excellent. And we just have to move one more window over here to Configure. So we were in Debug, move Program, and then Configure. Okay, we're now in the configure mode. These are all my digital inputs. So at this point, I have no digital inputs coming in. I just have an analog signal. In order to see that analog signal, I can double click on my analog card. So there's my PLC. There's my analog card, the TM2AMM6HT. I'm going to double click on this guy, and that'll provide me with my analog inputs here. The other way to do that is if you're looking at your digital inputs on the PLC, just move over here and click on this arrow, and it will move over to your analog card. Okay, I've labeled this as my analog input current, and the address for the word that's going to look at that is %IW1.0. Okay, so this is my first word on my analog inputs. I'll show you the wiring for this in just a few seconds. Okay, I've changed this from a 0 to 10 to a 4 to 20 milliamp signal coming in. And the normal range is 0 to 4095. Just for interest, I put the minimum here. So I've gone to here, done a customized range. And with the customized range, you can now go from minus 32,768 to positive 32,767. And just for graphical representation of the 4 to 20, I've gone here and I said, all right, this is 400 and this is 2000. And then it will just show us our 4 to 20 milliamp signal coming in. This is not the correct way to do it. The correct way to do it would be using the larger scale. But in this way, it just gives us a graphical representation. We're just trying to get these values right here onto the HMI at this point. Okay, once we've done that, we're going to hit Apply. Beautiful. So now I believe we've set up everything for the PLC. If we want, we can come over here and go to configure the data. And we can just see here that, let's see, our function, where are we? MW, we're in the simple objects right here. These are our digital inputs, and this is our word input right here, memory word, so %MW. And if I open this guy up, you can, we'll take a look at this in a little bit. This is not necessary at this point, but I've taken a memory word and labeled it analog input, and you'll see later on in my program, again, this is not necessary at this point, but later on I'm going to have my physical input on my analog card going to a memory word. But again, not required at this point. Okay, so what we did there was we went to program, then we went to configure, and once we were in configure, we went to configure the hardware. We gave our analog input a name. We changed it to 4 to 20. We used a customized range here, and we're going from 400 to 2000. Okay, so that's everything that we need to do for our Twido PLC. The next step is to go into our Vijeo designer and set up our HMI. Let's do that now. Okay, so let's go through this nice and slow, because this took me forever to get to work. The steps are nice and easy. You just have to make sure that you do all of them from start to finish. Okay, so the first thing we're going to do is go to IO Manager. We're going to right click on this guy, and we're going to provide a new driver. Okay, we're coming and looking along here, and we're looking for the Modbus TCP IP. Specifically, just the Modbus equipment. We're not using USB equipment. So TCP IP and Modbus, and Modbus equipment, and then we hit OK. Okay, now what we're going to do is we're going to put in the IP address for our PLC. So 192.168.2, and then the PLC that I'm using, I've given a specific address of 11. Okay, don't change this. I had said on previous videos to change this to a 1. Keep this as 255. Okay, we're also going to come over here and we're going to tag this IEC syntax. And once we've done that, put in the IP, keep this at 255. I changed that to 1, and that seemed to be the thing that wasn't allowing it to work. So keep this as 255, and then click this for the IEC syntax. Once you've done that, hit OK. All devices associated with this equipment were converted to IEC format. Yes. Okay, next thing we're going to do is we're going to go over to variables. So we're coming over here to variables. We're right-clicking on that guy. And then we're going down and we're going to link the variables. Okay, now you need to find the specific program, PLC program, this guy right here that we were working on. So I've named this 4 to 20 milliamps, and I'm working at home to get this working. So 4 to 20 milliamps home. I need to find this PLC program to find these inputs and outputs. Okay, so what I'm going to do now is I'll just pause for 2 seconds while I scroll through and find that folder that I have that in. Okay, so I have all my PLC stuff in one folder here. Here's my Twido Suite folder. I'm going to open that guy up, and Twido Suite PLC programs. So this isn't your standard place where the Twido Suite leaves its programs, but I've put it into this file folder specifically for my programs. So you'll have to find exactly where your program is. So we're looking for 4 to 20 home. Okay, so I'm going to open this guy up. So I'm going to click on this and hit open. And then it says no items match your search. Well, that's okay because I'm not looking for this .ccn. Okay, so I want you to right click on here and then scroll down, and we're trying to find this guy right here, the Twido Suite files .xtwd and xpr. So we're going to right click on those guys. We're going to again select the Twido xtwd and we'll hit open. Okay, so excellent. There are the two variables that I was talking about. So I have my memory word, and I've got the actual word that's storing the input current. Okay, I'm going to select both, but at this point I'm just going to make use of this guy right here. Okay, so we're going to select all, And that selects each of these guys. And now we're going to add them into our program here. After clicking S, variables will be created. This action cannot be reversed. Proceed. I mean, it can be reversed. You can delete them if you screw it up later on, but that's perfectly fine. So we're going to right click here. Okay, so those guys are added in at this point, and now we can close this guy up. Nice. So down here in the feedback zone here, we can see 2 root PLC symbols are red, and the link variables are finished there. If we go to our variables now and right click and open, then we've got PLC Modbus equipment here. And if we open this bad boy up, there we go. There's our analog input for our memory bit. And there's our actual input current going into our word on the PLC. Nice. So now we can link these to various things on our HMI screen. Okay, you'll see that there are 2 windows that are open right now. So I'm going to go back to my panel number 1. And the next thing I'm going to do is I'm going to drop in one of these guys right here. So a numeric display. If I click on this, I have numeric, string, date, and time. I just need a numeric display. So I'm going to click on that. Holding down the left mouse button, I'm going to create a button. And then click the left mouse button again. And then I'm going to put in all my configurations for this button now. Okay, so let's start with the style. So we'll come over here. And it looks like there's a number of styles here. We can browse again for each of these guys. Does it have other categories? No, it looks like that's it. I don't know. I always take too much time doing this. Let's do this, 36. Okay, at that point we've got that as our style. It's style 36. Let's make this guy the same color as our system config button down here. So we'll go to color, and let's see, we've got frame. Let's see, that's the inside right there, right? And we chose this right here. Okay, so that's 0, 128, and 255 for red, green, and blue. We'll hit OK. Oh, sorry, that's my frame. Let me go back. Let me try it. This guy for a frame. Okay, and then, oh, the plate. Okay, the plate on the inside is going to be this guy right here. Okay, that looks good right now. Beautiful. Okay, now we need to link this up to our PLC program. So we're going to go to General, and we're going to go here to Variable. And we're going to right-click on this guy. Sorry, no. We're going to left-click. There we go, left-click on this guy. And just be careful here because we have internal and external variables. Okay, so you can see, you can just make out that this is highlighted right here. Okay, so this is an external link, which is what we need. And if we go down here, there's our target number 1. There's our PLC Modbus that we made. And we're going to open up this window. And we're going to grab this guy right here, our physical word that the current is going into. Okay, or that is representing the current that's going into the analog card. And then we're going to hit OK. Excellent. Okay, you can see that we're going to keep the value as an integer. And I believe that's everything that we need. Our font, if we wanted to, we could do the same font with the 6x10. Just so it matches this guy right here. And we're ready to rock. Okay, looks good. Okay. I mean, if I was picky, maybe I want to do like a darker gray on the outside there, but we'll leave it like that for now. Nice. Okay, we've done. Whoa, easy now. We've done quite a few changes now. So let's go over here to hit Selection Tool so that we can actually just stay on the screen there. Okay, and now that we've made those changes, we're going to go to File, and we'll just save the project. Nice. Okay, so let's drop in the tank now, because this is now going to provide us with a numerical display of exactly what we're seeing on our PLC. But it'd be nice to have that tank on the side that's going to change the level based off of this value that's coming in. Okay, so you can see over here that I already have the tanks available. The way that I've gotten there is I've gone to Tool Chest Folders, then I've gone to Graph, And if you go down here to tank graph, you can see that that folder is open right now. So again, it's under tool chest folders, it's under graph, and if you scroll down here to tank graph, then you'll get each of these guys. Right on. Then it's just a matter of grabbing whichever one you want. I think when we started there, I had this image right here, but you could grab any of these guys, whichever one you like. So I'm going to grab this one right here to match with what we had at the beginning of the video. We'll drop it in. Now this isn't as large as we had it, so I'm going to grab this and pull it down. And that way I can have a larger tank to represent the level in there. Now, if I click on this guy and then just use my arrow keys, nice, then I can just finesse this guy over. If I'm using the mouse buttons, then it moves it over quite a bit. But if I use the arrow keys, I can just finesse it so it's nicely placed on the page there. Very nice. Okay, let's save as we go. Okay, so next thing we're going to do is we're going to link this to our PLC as well. So we're going to click on this guy. Now, you'll find that it's hard to click on this one. It keeps trying to click on the background here because that is an image there. So I'm going to click on the outside here and then try again. There we go. Now it's ready to go. So I'm going to right click on this guy. Okay, and then the properties are right here. So here's everything to do with this image right here. So it says that it's not linked up to a variable and it's screaming red at us right now. So let's go over here to these three dots. Let's open this up. So we're going to left click on this. Again, we're going to an external variable and we're going to click on this guy. And again, we're going to grab that input IW 1.0 and hit OK. Looks good. Okay, the values there, it says from 0 to 100, but I know that that value on my PLC is going from 200 to 4,000. So let's go to here, right? It's 200. It's going from 400 to 2,000. A little bit of dyslexia there. Okay, matching with my 4 to 20 milliamp current. So 400 to 2,000. So we're going to click over here, and we're just going to change these values for now from 400 to 2,000. Beautiful. Okay, looks good. We'll save that bad boy. And at that point, I believe everything is set up. So again, we're going to go over here to build. We're going to clean all. Then we're going to validate all. Okay, then we're going to build everything. Okay, looks good. And then is there anything else that we're going to do? Build a target validate. Looks good. The only other thing, I wonder whether we need to, we don't have to update the link, but let's do this just in case. I'm not sure whether we need to do this, but let's validate the variables as well. Okay, everything looks cool. So we're ready to go. Let's build it one more time just to make sure. Okay, right on. So green lights all the way across. Looks like we're cool. So now let's see if we can download this to our HMI. Okay, so to download this, again, we're going to go here to build. Let's clean that up. And let's go to download all. Okay, let's delete the runtime data as well, just in case there was something left over. We'll hit yes. And this will compile it on the computer. Then you'll see the screen go dark. There it goes. And now it's compiling it on the HMI. Okay, so again, one of the key things to remember is that you have downloaded your PLC program to your PLC and you're in the run mode. That way the values will transfer over to the HMI. And now we've downloaded this guy and they look exactly the same between the computer screen and the screen that's in front of us on our HMI. Very nice. Okay, so this is the last thing to check, guys. Does the value change? So right now I have my piece of metal right up against my inductive sensor. That's the minimum amount that I have coming out of my inductive sensor. On the meter it's showing 4.6. On the, so 4.6 right here, and we're reading 4.52 on the HMI. What are we reading on our Twido suite? 4.53, 4.52. Okay, so those values are identical now. Okay, so now what you'll see is I'll change the position of the piece of metal in front of the inductive sensor, and you'll see that this value changes, this guy changes, and this guy, and they should be basically the same now. So as I move it away, the signal will increase from 4 up to 20 milliamps. We can stop it at any time and double check our values, right? So right there we got 16.08, right? And I got 16.08 and I'm reading 16.3 on the actual meter. I'm in between two values here, so these lights are just going back and forth. You can hear them chirping above, and you can see them just changing slowly. Okay, so let's increase this distance till we get to the 20 milliamps. Very nice. Excellent. So we have 20 milliamps on the meter. We have 20 milliamps on our digital display here on our HMI, and the value right here on our PLC is identical to that on the HMI. Very nice. If you got all this working, nice job. Nice job. You would not believe how long this took me to figure out. So many videos in so many different languages. Oh my goodness, it took so long to figure out. But this is awesome. Now we've got a way to take that analog signal, that 4 to 20 milliamp signal, and have that go into our display. We can show that value right there on our numerical display right here. And we've got this cool graph showing us the level in the tank. Nice. Now we've got all kinds of possibilities. We can now use this for our level lab for our PID to show our level in the tank. We could use this for temperature labs. Anything that's giving us 4 to 20 milliamps, we can now graphically show on our HMI. All right, guys, thanks very much for your patience. Hopefully everything worked out and you were able to follow through and I was clear on all the steps. All right, guys, thanks for your view. We'll see you guys soon.